Alright, good morning everybody. So today what we're going to be talking about is polynomial graphs. We started in on this a little bit last time. Now we're going to talk about it a little bit more. Okay, first thing we're going to start off with is something that we have talked about before, maximums and minimums. So just to review statement, maximums and minimums when we do quadratics, those are the parabolas, they always occurred at the vertex. Oh, I'm going to need a new marker here. Those always occurred at the vertex. And we'll draw a picture of what that looked like. We had a quadratic and we had parabolas. If we had one like this, then we would have a maximum right there. Or the other way that a parabola could face, instead of opening down, it could open up like that, and then at the bottom, that's where we had a minimum. Okay, so these are things that we have talked about before. We're just going to take it a little bit further. In general, for all polynomials, not just quadratics, a maximum is the highest point in its neighborhood. It's the highest point in its neighborhood, and you might be able to guess then a minimum is somewhat the opposite. If a maximum is the highest point in its neighborhood, a minimum is the lowest point in its neighborhood. Okay. So maximum is the highest point, a minimum is the lowest point. And it's not too difficult to imagine what that looks like. So if we have something, a polynomial that makes a graph that, say, looks like this. Okay, then we have two low points right here. Here's one, here's the other. So these are our minimums. Because if you look right around this point, here's this point, look right around it. Just in the very small space next to it, there's no point any lower than that. And the same thing happens down here. Just in the small area around this point, there is not another point that is lower than that. And so we can also pick out a couple of maximums then. Go right here. And if you look at these maximum points, look nearby this point. If you look in just the area just right around it immediately, there's no point higher than that one, and the same thing over here. There may be higher points over here, but just in the small area around that point, just that little tiny piece, that is the highest point for that little section. So that's what we mean by neighborhood. If you look just right next to it, not at the whole graph, but right around it, is there any points that are lower or higher? If no, then you have a maximum or a minimum. Okay? All right. So when we talk about these things together, so if maybe we don't want to just talk about the maximums, maybe we don't just want to talk about just the minimums, we want to talk about both of them. So when talking about maximum and minimum together, they are called extrema, because they're the extreme points of a graph, or turning points. Okay? We call those extrema or turning points. Okay, and so when we have a polynomial or a graph that has degree n, then it has at most n minus 1 turning points. Okay, so if the degree of your polynomial is 8, the most times it can turn around is 7. And if your degree is 5, the most it can turn around is 4 times. Okay? So we've talked about maximums and minimums. Next thing we're talking about is zeros, and that's going to be what's going to go in here. The review statement here is when a graph crosses the x-axis, You sometimes call that x-intercept, but the name we're going to keep sticking with is zeros. Okay, so wherever you cross the x-axis, we call that a zero. Okay, and so what does that look like as far as a picture goes? So let's say we have something like that, then there, there, and there. Those are all zeros where we cross the x-axis. Okay, so if we have a graph, suppose we have a graph that has zeros at -3, 5, and 9, then that means x minus 9, x minus 5, and then x plus 3, because that one's a negative. That means all of those are factors of the polynomial function. Okay. So when we have zeros, those zeros contribute to some factors of the polynomial function. Now, each factor contributes 1 to the degree of the polynomial. Every time that if we chain together these and multiply them, every time you add one of these sets of parentheses, these binomials, every time you add one of these, it contributes 1 to the degree of the polynomial. So if a graph has 4 factors, aka 4 zeros, then the degree of the polynomial is at least 4. Has to be at least 4. Cannot be smaller than that, because it has that many zeros. You have at least that many of those. You have at least 4 factors as well. Okay. Now, moving on. The next thing we're going to talk about is how to graph a polynomial using a graphing calculator, because graphing one of these things is really laborious, and a lot of times you just have to plug in points and then try and get the shape of the graph. So we tend to focus on those things that we've been talking about so far. So when we make a graph with a graphing calculator, the first thing you want to do after turning it on is press the y equals button. That's where we're going to put in our equation. Okay. So then we type in the equation, and to enter an x, you have to press alpha, and then the button that has a capital X above it. It won't be on the button, it'll be above it. All right, and then to enter an exponent, it's the same thing as if you were using a regular scientific calculator. You use call it the caret, where it looks like a little up like that. And that's how we'll put in our exponents. Okay? Once you've done that, to view the graph, all you have to do is press, amazingly, press graph. And then it'll show you the graph. When you sketch the graph, so you'll be looking at the graph on a graphing calculator, and then needing to transfer that graph onto your actual paper, or just copy it. What you want to focus on is the extrema, or your turning points, and also the zeros. Okay, so that'll be what you want to focus on, making sure that if you have those points accurate, then the rest of it you can just kind of sketch. It doesn't have to be perfect in between, but we want these points to be as accurate as possible. Okay, so now we're going to do a couple examples of how to type these into your graphing calculator, so you can graph them with a graphing calculator, which is useful because you'll be able to use one of these for the SAT. All right, so the first thing we wrote down, the first step, is we press the y equals button. So that's what we're going to do. We're going to press that y equals button. And it looks like there's already some functions in this one, so we're going to go ahead and clear that and clear that. Right there at the first one, you don't need to, I mean, if you want to go down to one of the other ones, that's fine, but the first one will do just as well. So our first example in your packet is a negative x to the third. So we need negative alpha. To do an x, we need alpha, and then find where the x is. So that would be right here on that store button. So there's negative x. Use the caret button to do the exponent with 3. Press the arrow key to come down, so we're not in the exponent anymore. And then plus 2, we need an x, so alpha x. Caret to do our exponent of 2. Use the arrow to get out of the exponent spot, and then minus 4. So now we've entered that function. Now to look at the graph, all I got to do is press the graph button. There's our graph, and there it goes. There you've got your graph. Again, to get this graph into your packet so that you can, all you need to focus on is the extrema. So focus on our minimum right there. Focus on that maximum and our zeros. Everything else in between, just do the best you can to make it look like it has the same shape, and that's all you got to do. All right, so let's do one more. We'll go back to y equals. We're going to clear that out so that we can start fresh. And the other example that we have in our packet is -2. We need alpha x to do an x, caret to do the exponent of 4, arrow to get out of the exponent, plus 5 alpha x, exponent of 3, minus 4 alpha x, and that is squared. And the last thing we have is a plus 1. Enter. So now that function is in there. We go to graph, and voila, there is our graph. And we can just copy that right onto our straight onto our graph in our homework in our packet. Okay, so let's go ahead and do a couple of examples here of we're going to be given a graph, and then we're going to analyze that graph. So here's what we need to do. For each graph, we need to estimate the x-coordinate of each turning point and indicate if it's a min or a max. And then we need to estimate the x-coordinate of each zero, and then using that, we will determine the minimum degree of the polynomial. And so you notice we're going to be focusing on the x part here. So it's just all about how far to the left or how far to the right do we have to go to get to these points. And so first thing we're going to do is look at our turning points. So if we look at here, we have one turning point right there. Okay, and because this is the high point, it's a high point, that makes it a max. And we're over 1, 2 to the left. So we have a max at -2. And then if we keep going, look for another place we turn around. That's right here at the bottom. Since that's a low point, that's a min. So we have a min at, it's over from here, it's just over 1. So we have a min at 1. And then we keep going. And then lastly, here's the last place where we turn around. And it's a high point. So that makes it a max at 1, 2, about 2.5. We don't have to be perfect here. 2.5 is good enough. So we are estimating here. Some of them are not going to be on a line exactly. You just take the best guess at it that you can, and as long as you're, within a couple 0.1 or 0.2, that's just fine. Okay, so now let's look for our zeros. So we look on the x-axis. Where do we cross the x-axis? Here's the first point. That's at 1, 2, 3.6 to the left-ish, something like that. So we have a 0 at -3.6 or so. And if we keep going, we have one other place that we cross the x-axis right there. That's at about -1/2, -0.5. And that's good enough. So we have answered part A. We even found the zero, so now we are done with part B. Part C, determine the minimum degree of the polynomial. Well, we talked about before that every time we have a zero, that contributes at least 1 to the degree of the polynomial, or each one of these contributes 1. So that means the degree is greater than or equal to, so that means it's at least 2, because we have 2 zeros. And so this is a complete problem. Okay, so now let's do one more. All right, so same thing. We're going to start out with finding our minimums and maximums. If we look at the graph, where's our first turning point? It's about right there. Okay, and it's a high point, so that's going to be a max. And we're at about 1, 2, 3.5 to the left, so -3.5. Okay, let's keep going. We got another turning point right here. This is a low point, and so that's going to be a minimum at 1, 2, a little bit more than 2.5 to the left, so -2.6. We keep going up our graph. Here's a turning point here. That's a high point, so that's a max. And that is at about 1 to the left. So we got a max at -1. Keep going. And here's our last turning point right here. That's a low point. So we have a minimum at, it's about 1.5. If we look from the center to the side. From the center, we have to go to the right 1.5. And there you go. So we found our minimums and our maximums, our extrema. Now let's see if we can't figure out our zeros. All right, starting from the left, we just go right across the x-axis, about right there. It's not quite at, looks like it's just almost at 2, so that's a negative, we'll say negative 1.9. Keep going, and then there's one right about here. It looks really close to 0, and so if you put that there's a 0 at 0, that would be fine to me. That looks a little bit to the left of the center, so we'll say that's negative 0.1, just barely to the left of this origin there. Keep going, one more 0 right here. 1, 2, 3, and just almost half, so we'll say 3.4. It's not quite half, so 3.4. Okay, so we have found our zeros, and now because we have 3 of them, that means our degree is greater than or equal to, so it must be at least 3, because we have 3 zeros. Okay, keep moving. All right, our last examples here. So they're going to tell us some things about the graph, and then we have to make a sketch. So what is important to know is in between these things, it really does not make a huge difference as to what it looks like. It doesn't have to be super accurate. Like I said before, even with the graphing calculators, we're focused on the zeros and the extrema. So we have an even function, so that means it needs to go up, up, or down, down. And have to point the same way at the end because it's even. With zeros at negative 2, so here's negative 2, and at 1, and at 3, and at 5. So all that matters is that we cross through these dots, and the ends have to be the same. So I could just start at the bottom if I wanted to, and I'm going to go through here, and then through there, and then through there, and then down here. Okay? I have met the requirements of what the problem is asking. It's even because the ends go the same way, and we have zeros at negative 2, 1, 3, and 5 because I went through the graph at those points. Other than that, it really doesn't matter what the graph does. This is plenty satisfactory, and this would be marked correct. Let's do one more. A 5-degree function. So 5-degree function, we talked about before that when we talk about the degree, we can only have so many turning points. And so if we have a 5-degree function, our turning point, most number of times that we can turn around is 4. At most, 4 turning points. Okay, we need zeros at negative 4 and negative 1 and 3. So 1, 2, 3. And we have to have a maximum at negative 2. So if we go to negative 2, we have to have a max here somewhere. And we see that we got to go through these 2 points. So we should probably go above those 2 points. Doesn't matter how far up we go, as long as we're 2 to the left. Okay, so we have a 5-degree function. So if we have an odd degree, that means the ends should point the opposite way, something like that, or something like that. We'll start from the top this time because we started from the bottom last time. So we'll come right here. We'll just come down and touch that point, and then we'll come back up. So we have 1. This is now going to be 2 turning points. Down. So 1, 2, 3, and then let's just touch this one so that we can come back down without making extra zeros. So something like that. Just to make sure, do we have at most 4 turning points? 1, 2, 3, 4. So we have no more than 4 turning points, so that's what we need. We cross through our zeros, and we hit our maximum that was required. So this problem is complete. This would be marked totally correct. Again, it does not really matter what it does in between as long as we have at most 4 turning points and hit the points that we need to in the graph. And then we have to follow the degree, even up as well, which we have opposite directions.